So this video is going to serve as like an intro for this unit of expressions and properties. In this unit, we're not only going to go over numeric expressions, but we're also going to go over algebraic expressions. So we need to figure out what's the difference between the two before we can go any further. Okay. This page is just to kind of outline what are the main learning targets that we're going to go over. Okay. And I like to break it down in terms of like, what's the difference between all of these? Okay. So if you look, we have a writing 6A, and we also have um, a solving 6B. They have the same domain, which is kind of like the same overall topic, but they're a little bit different. So this part here is identifying and talking about translating all of that with numerical expressions. Okay. This also talks about order of operations, right? Evaluating numerical expressions, which is a fancy way of saying order of operations, right? Translating phrases or words into numerical expression. So this is all numerical expression stuff, which is basically numbers, okay? And then this whole set of learning targets has to do with algebraic expression. So this is when we're going to start seeing variables and being able to simplify some of the expressions. So here we go. To start us off, difference between expressions and equations. Definitely need to know that. Okay. Then we're going to talk about what are the parts of numerical expressions and how do you solve numerical expressions. And this stuff is all a review, so do not freak out. Okay. What is an expression? Okay. Here is a page that has to do with expressions. Take a look at it real quick. And here's an equation. Expressions. Equations. What do you notice that is different between the two? Hint, it's circled in yellow on this page. Equations have equal signs, right? Equation, 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 equal signs, right? It's a math sentence that states that two things are equal to one another. This little problem over here is equal to 26. This little thing here, you can look at it as a fraction or the division problem. It's equal to this division problem, okay? An expression is kind of like an incomplete sentence in ELA, right? An expression, there's no equal sign. It doesn't tell you what anything is equal to. It just gives you the problem part, right? Okay. So expressions, equations. All right. If that's still confusing for you, this Mr. J goes through and actually gives you some examples and you can practice with him. I'm not going to though. Okay. So what's a numerical expression? Here are some examples, right? Numerical expressions are just that. They don't have an equal sign and all they have are numbers, 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 numerical. Okay. So in numerical expressions, instead of calling them numbers now, in algebra, we're calling them constants. You constantly know that this is an 8. You constantly know that this is 43. And you constantly know that this is worth 13. There's no confusion. Okay. There's no variables, nothing confusing. Constants are just numbers. Okay. So a numerical expression always represents a particular number. For example, this numerical expression 5 plus 20 minus 9, right? It represents the value 16, right? So when you're going and solving it, it's going to end up equal to 16, right? So the following are some examples of numerical expressions. They're just problems, right? Notice you could solve all of these, right? They're all numbers, numerical. None of them have equal signs, so they're called expressions. Cool? Okay. PEMDAS. We've already done this. We did this at the very beginning of the year, right? Order of operations. So when you're given multi-step problems like this, 9 times 41 plus 4, multi-steps, right? There's 2 different problems in here. You know which one you have to solve first in order to get the correct answer. Okie dokie. 5 divided by 30 times 3, right? So if it's a multi-step problem, there are certain rules that you have to follow. You have to do PEMDAS. You have to do it in that order. Parentheses first, then exponents. Then multiplication or division, whichever comes first from left to right when you're reading the problem from left to right. Then the last part, addition or subtraction, whichever you see when you're reading from left to right. So take a look. Okay. When we talk about an exponent, right? If we got to the E and I said exponent and you were like, what? This is a refresher course. Your exponent is the little number. It's the little tiny boss that sits on the shoulder of your base number, right? And it's saying, like, hey, 3, I need 4 of you. Okay. So this 3 is saying 3 times 3 times 3 times 3. I have it 4 times. Okay. So it does not mean 3 times 4. Otherwise, we would just write 3 times 4. Okay. It means you have the number 3 4 times, right? 3 times 3 times 3 times 3. So when you solve this, it's equivalent to 81, right? Definitely not 12. Okay. So PEMDAS rule, order of operation rules, right? This is exactly what I was talking about. Look at these long math problems down here. It looks kind of complicated, right? But if we go through PEMDAS, we're going to say, if I look at this guy right here, right, what would I solve first? Well, P for PEMDAS, right? What does the P stand for? It stands for parentheses, right? So I have parentheses right here. Okay. So inside my parentheses, I have 12 minus 9, and I know that's worth 3, right? So now that I'm done with the parentheses, okay, I'm going to bring down everything else. 37, right? I'm going to bring down the subtraction sign I haven't used. I'm going to bring down my multiplication sign and the 3 that I haven't used. And then see these brackets here? The brackets are just another set of parentheses. They just made them a different shape so you wouldn't get them confused. Notice what I saw first were the inside parentheses. We call them nested. Basically, you're working from your inside to outside. Okay, so always solve your inside nested parentheses first. And now we are ready to solve the outside parentheses. Okay, so we're still on the parentheses step. Okay, inside my parentheses, I have 37 minus 3 times 3. Well, I still have to apply order of operations. So PEMDAS says parentheses exponents. Do I have any exponents inside that parentheses set? I do not, right? So PEMDAS, PE, and then I always put the M and the D side by side, right? Because it has nothing to do with multiplication has to be first and division is second. It's whatever you see first when you're reading from left to right. So do I have any multiplication or division? I do. I have multiplication, so I have to solve this first. 3 times 3 is 9, right? So then I'm going to bring down everything else that I have not used. So I'm going to bring down my 37, my subtraction sign, and my parentheses, right? And then I have that divide by 7 off to the side. Okay. So again, still on the parentheses step. So finish out parentheses here, and then we can move on and we can divide by 7, right? So inside my parentheses, I have 37 and I have to subtract 9, right? So that means I have 28 altogether. I'm running out of room, so I'm going to put the 28 over here, right? So 37 minus 9 is 28. And I'm going to bring down or bring over my dividing by 7 sign, okay? And that's what I have left to solve, right? So I'm going to do 28, and I'm going to divide it by 7, and now I have 4, okay? So that's a way of taking a multi-step problem and breaking it down. Look inside your parentheses first, then your exponents. Multiplication or division, we just didn't happen to have any addition or subtraction in that problem. But if we did, we would work from left to right, whichever came first. Okie dokie. All right, here we go. Translating vocabulary into operations and translating phrases into numerical expressions. So it's kind of the same thing, okay? We're working back and forth. We can start with words and turn it into an expression, or we can start with an expression and turn it into words, okay? There's 2 different videos that are really helpful. You can watch those on your own through the playlist. I'm going to walk you through this part, okay? So let's start with an expression. Notice the expressions like your actual problem, right? Can you turn it into a phrase? Okay, so when they say a word expression, the phrase, okay, this is your phrase over here. Anytime you're just using words, which means you need to know your vocabulary, okay? So this says 8 times 43 minus 13. 43 minus 13. Okay. There are other ways to write it. Okay. We could say 8 times, right? We still see the 8 times. But instead of saying 43 minus 13, we're going to say the difference of 43 and 13. That means the exact same thing. It's just a different way of saying it, right? Okay. What about this one? 12 times the sum of 5 and 25. See how there's the sum? Sum means to add, right? So I could say 12 times 5 plus 25. Okay. But instead of just looking for the word plus, not seeing it and being like, I don't know what this means, the word sum. Okay. When you see the word sum, we're finding an addition problem in there somewhere, okay? And then here we go. The sum. So we just knew the sum is addition, right? So the sum of 320s, 320s, right? I have 20 3 times, 320s, and 3 5s, which means I have 5 3 times. 3 5s. So there's all sorts of different ways that you could say this. Stop and think about it for a second. What's another way that you could write this, right? You could say the product of 20 and 3 plus the product of 5 and 3, right? Because product also means you're multiplying stuff together. So there's all sorts of ways, right? We just need to practice your vocabulary so you can go from your numbers to your words and your words to your numbers back and forth. Okay. Here we go. Write an expression to match the words. So Russell has 14 fish in his tank, and then he buys 5 more. So you need to know, in order to get 5 more of something, you add 5, right? Susan has 128 bucks in savings, and then she spends 4. Spending 4 is the same thing as subtracting 4. Kim buys 5 movie tickets. Here you go, you got 5. Each ticket costs $8. When you hear the word each, that means you're multiplying, right? Each cost $8. So you're taking each of those tickets and multiplying it by the cost. And then the last one, 5 players share 45 cards equally, which is the same thing as saying you got to divide it up. You're going to divide it equally, right, between those 5 players. So you got your 45 and you're dividing it by 5 players equally. Okay. Screenshot it if you want to. More practice. Expressions with parentheses. Okay. The meaning of the words in a problem will tell us where to place parentheses. So, which expression matches the meaning? Okay. So, Dylan went to the fair for 3 days, right? 3 days. Each day he took 15 bucks. At the end of each day, he had 5 left. How much money did Dylan spend total? Is $15 minus 5 correct? So each day he took 15 bucks. At the end of the day, he had 5 left over. Well, if you take 5 minus 15, are you going to end up with 5 left over? No, you'll have 10 left over. So that's not correct. Okay. So they're kind of walking you through this. Underline the events, circle the numbers, right? So think about it. Each day he took 15, right? And at the end of each day, he had $5 left over. Okay. So what's happening? Each day for 3 days. So that's why we're multiplying by 3 because it happened 3 times, right? It happened on the first day, the second day, and the third day. Each day for 3 days straight this happened, right? Each day he took 15 bucks and had 5 left. He did this for 3 days. So this is how much he spends in 1 day. Okay? To show how much he spends in 3 days, we need to multiply this by 3. What the heck? I just realized this isn't correct. I don't even know where I got this from, but this doesn't make any sense. He's taking $15 and at the end of the day, he has 5 left. Oh my gosh. Seriously, where did I get this from? That makes no sense. He has $5 left over, right? So if I subtract 5, I don't have $5 left over. I would have 10. Oh my goodness, right? So we would, I mean, if we want to make it obvious, we would be taking away 10 for $5 left over, right? But yeah, so this isn't even correct. Bloop, bloop, bloop. I think it's good to show that there are 3 days. So if he's doing it each day, you're multiplying by 3. But yeah, this stuff is janky. I wonder where, I really want to know where I got it from. Okay, so no, we're not going to do that anymore. That one is not going to work. So here we go. Here's another one. Keep going. How do I write a numerical expression? So words that mean adding, right? You can this plus this, you're adding. The sum of two numbers. If something's increased by a certain amount or more than something, if you're adding to it, or if you need to find the total. Those are all adding, right? Subtracting minus something else, or finding the difference between two numbers. If you have a number and it's decreased by another number, right? Or if you have less than someone else, you're subtracting, right? Or if you're taking away from something, or if you have fewer than a certain amount, all of those are subtracting, right? So the multiplying one I think is tricky because if someone says you have double that amount, or if you have twice that amount, or if you have triple that amount, right? Sometimes kids get funky and can't picture that in their head. If you say I earned double what I made last year, that's just multiplying by 2, right? If you say it has triple the amount of chocolate in it, you're just multiplying by 3. Okay. Times is obvious. Multiplying by is obvious. Product means multiply. That's still a word some kids don't remember, though. So that's a big one. And then dividing, quotient. Quotient is another vocab term that kids forget. So quotient and product and sum, I would say, really throw kids off. If you're dividing, you're sharing equally. That's what that means. Or you're splitting them into even groups. Okay. So again, if you want to take a screenshot, you might want to screenshot it like this, right? So that way quotient, product, and sum all stick out. Okay. Really good vocab sheet. Same thing here. If you're adding things together, it's the sum. These are called add-ins, which is so funny. I don't know many people that call them that, but that's the true terminology, right? The difference is the subtraction problem, quotient, and product, right? Your factors are the numbers you're multiplying together. Your product is your answer. So this is another great screenshot. And then how is an algebraic expression rewritten as a phrase? Okay. So again, 2 huge videos. You can watch those in the playlist. I just kind of want to go through this. The difference of 9 and x. So let's practice this together. Difference means subtraction, right? So if I'm finding the difference of 9 and x, there you go. 6 more than n. If you've watched other videos, you know the word than is a trigger word. You want to make sure that tells you to switch the order. I want to have 6 more than what I started with. So n is what you're starting with, and then you want 6 more than that. So you switch the order. Okay, it's not always the exact order of the words. The product of x and 10. Technically, product means multiply. So technically, I could say x times 10, right? But in algebra, We like to shove them up against one another like this, and your number always goes first. Okay. The difference means subtraction. The difference of x and 9, right? So notice it does depend on the order of the words for the difference, right? The quotient means divide, right? So if I'm trying to find the quotient of n and 5, I could write it like that. I could also write it like a big kid and say the quotient of n and 5. This means n's being divided by 5. This means n is being divided by 5. 15 more than twice the number. So remember, than is your trigger word. It means you're going to switch the order of your stuff. Okay. So I want 15 more than what I have to start with. I have to start with twice a number. So I'm going to take 2 and I'm going to multiply it by a number. So I'm going to just say 2 times n. Okay. Twice a number. And I need 15 more than that. Right? So that than word, more than, told me to switch the order. 6 less than, again, than is your trigger word. So I need 6 less than. I'm going to put 6 less at the end, right? My order is different. I need 6 less than the product of 12 and y. Product means multiply. So I'm going to write the product of 12 and y like this because I like to get in the habit of multiplying them by shoving them together. And I need 6 less than that. So the 6 less than's at the end. Okay. Whew, this one's hard. 5 more than. So the than is your trigger word, right? That means it needs to go at the end even though it's at the beginning. So I need 5 more to be at the end, right? 5 more than twice the difference of a number and 13. Well, the difference means subtraction, right? So I want the difference of a number. So I'm just going to use n for the number. Difference of a number and 13. Okay, so there's my difference of a number and 13. And I need twice that amount. Okay, so if I just put 2 times n plus 3, or sorry, 2 times n minus 13, right? This is twice the difference of n and 13. And then I need 5 more than that. Whew! Okay. That one's tricky. That's definitely a challenge, okay? And then algebraic phrases and expressions, let's practice. I have a quizzes that you can use if you want to practice. And then I also have worksheets and the answer keys are in there. So these are linked inside your playlist. Okie dokie. The next section of learning targets that you want to go through is finding out what's an algebraic expression, how to identify those parts, and then how to plug in a value to solve or evaluate. Okay, and that's a different video. It's already been made, so check it out.